Hello, ladies and gentlemen. Welcome back to Math 30-3, Chapter 2, Section 1, Accuracy and Precision, Part 3. We just talked about measurement uncertainty. Now, a few examples. The smallest unit on the measuring device used the smallest unit on the measuring device used determines the precision of a measurement. The thermometer would allow a precision of 1 degrees Celsius or 2 degrees Fahrenheit. So here, the temperature appears to be approximately 10 degrees Celsius, minus 10. So we would say minus 10 degrees Celsius. Now the precision is 1 degree. I should change color, shouldn't I? So that would be a total of 1 degree off, so plus or minus 0.5 degrees Celsius. Okay. Now, if we're measuring this in Fahrenheit, that looks to be 0, 1, 2, 3, 4. Now each line is 2, so that's 2, 4, 6, 8, 10, 12, 14. So it looks to be 14 degrees Fahrenheit. Now, plus or minus 1 degree Fahrenheit. So it could be as low as 13 degrees Fahrenheit, high as 15. But I would rather use centimeters if you don't mind. All right, so state the precision and uncertainty of the following measurements. A ruler marked in millimeters is used to measure a pencil as shown. So precision here, this goes to 1 millimeter. So precision to the nearest millimeter. Uncertainty plus or minus 0.5 of a millimeter. The uncertainty is half the precision. We measure to the nearest 1 millimeter, so we can be off by half a millimeter either way and still be okay-ish. So an odometer records distance traveled to the nearest kilometer. So precision is 1 kilometer. Uncertainty is minus 0.5 of a kilometer. So your odometer is an old one. The pre-electronic stuff? Yes. Not that you remember that far back. Outside temperature is recorded as 12 degrees Celsius. Stops at 12, so the precision is to the nearest 1 degree Celsius, which means our uncertainty is plus or minus 0.5 degrees Celsius. So the temperature here, 12 plus or minus 0.5 degrees Celsius, as low as 11.5 and as high as 12.5 degrees. So Harpreet says it takes him about 5 hours to drive from Vancouver to Kamloops. All right. So the precision is 1 hour. The accuracy is plus or minus 0.5 an hour. Now, somewhere along the way, we're going to realize half an hour. Another way to say that would be 30 minutes. Though that's not as good a way to say it. Plus or minus half an hour is better. But yes, we can talk about that later. I'm just lazy. So, Genevieve is mixing juice in a jug marked in quarter liters. She measures the amount of juice in the jug to be 2.5 liters. Write the measurement of the juice in the jug in the form measured value plus or minus measurement uncertainty. Well, we know it's 2.5 liters, but the thing is, it is to the nearest quarter liter. Sorry. My apologies. So that is 250 milliliters. 0.25 liters, which is 250 milliliters. So this jug only has some lines on it. It's not great for measuring stuff. So our precision is to the nearest quarter liter, or 250 milliliters. So our accuracy, or uncertainty I should say, is half of that, 0.125 liters. So 2.5 liters plus or minus 1.25. So what's the range of volume that could be in the jug? Well, the smallest amount, 2.5 liters minus 0.125 liters, is 2.375 liters. The most, 2.5 liters plus 0.125 liters, 2.625 liters. Now, you're all going, who cares? I do. Well, actually, and you will eventually, because someday you'll be old enough to go to a bar and COVID will be over and you can go there and buy this stuff called alcohol. Evil substance. Very evil. And you'll find that some bartenders will shortchange you. That is, put less alcohol in the drink than they're supposed to. Yes, they're allowed a certain range, but you want to be careful and make sure they're not shortchanging you. Yes, not that I know anything about alcohol in bars, because, you know, well, not that I'm going to say it loud, because you're far too young and innocent to know about that. So, last thing I want to talk about is adding and subtracting values when you have uncertainty. So when adding or subtracting measurements that each have uncertainty, the combined value will also have an uncertainty. Okay? The uncertainty of the final amount is the sum of the measured uncertainties. Okay, so this is important. For example, Marcy's a carpenter. She's installing sheets of plywood as subroofing on a balcony. She's measured two of the sheets to be 2.25 meters and 1.3 meters long, using a tape measure marked in centimeters. Write the lengths of each sheet of plywood in the form measured value plus or minus measured uncertainty. Okay, well, right off the bat, the uncertainty we can measure to the nearest centimeter, which means your uncertainty is precision equals 1 centimeter. So your uncertainty is plus or minus 0.5 of a centimeter. Notice half a centimeter is too small plus half a centimeter too big equals 1 total centimeter? Yes. So here the plywood was 2.25 meters, so that's 2.25 meters plus or minus 0.5 centimeters and 1.30 meters plus or minus 0.5 centimeters. Now, technically that's correct, and I'm okay with that, but what we have here are two different units. So I'm hoping you remember 100 centimeters in a meter. So you just multiply by 100. So it's 130 centimeters, so minus 0.5 of a centimeter. Now, this can get important pretty quick. You do any carpentry, any building, you really, really, really do want your stuff to measure up and add up. Bad things happen if you're a couple inches short. You can always trim the wood, but you can't make it bigger. Oh God, no. Don't ask me how I know that. Do not ask me how I know you cannot make a floor joist bigger. Anyway, so what is the total length, including uncertainty, of the two sheets if they are placed end to end? Okay, so the total length is 225, we'll leave it as centimeters, plus 130 centimeters. So it's going to be 355. Now, the important thing here is the uncertainty. Total uncertainty. is 0.5 centimeters from the first. So that's plus or minus 1 whole centimeter. All right. So what I should be saying here, make a little more space. The advantage of it is 355 centimeters of plywood plus or minus 1 centimeter. Now, like I said, you do any sort of building, you cut it short, you're kind of screwed. So, now, it's a little long, so what she do? So Marcy needs to shorten the 2.25 meter sheet of plywood. She cuts a 30 centimeter section from the end. What's the new length of this sheet, including uncertainty? Well, it's 225 centimeters minus 30, 195 centimeters. Now, the problem is, I should be saying 225 centimeters plus or minus 0.5 centimeters minus 30 centimeters plus or minus 0.5 centimeters. I really should be writing it this way. Actually, should I? No, as long as you realize 195 centimeters plus or minus 1 whole centimeter. So that's what I should be making a note of here. We add our uncertainties. Now, as I said, carpentry, this becomes important, but it's important in a lot of things. You're painting. You have to know how big an area, how much paint you need. I knew a fellow years ago, he bought gold foil for computer chips back when they made them in Canada. That was a while ago. But he literally went out and bought foil by the square, paid for it by the square inch. Excuse me. He wanted to make darn certain how much he had, because he did not want to get shortchanged. All right, now, this is uncertainty, adding and subtracting. That's it for me. If you've got any questions, shoot me an email. Otherwise, work on the worksheet. Good luck.